All right, so here's a three-step model. So using mathematics to solve real-world problems can be broken down into three steps. First, we have a real-world problem. Then we're going to construct a mathematical model. Then we're going to solve that mathematical model and get a solution. And then we're going to interpret that solution and back into what the real-world problem is. And so basically, we're writing our answer in terms of what the real-world problem is asking for. And so that's kind of what it shows here. And so that means, guess what? We have to do a real-world problem. So it says a company that rents small moving trucks wants to purchase 25 trucks with a combined capacity of 28,000 cubic feet. Three different types of trucks are available. One is a 10 foot with 350 cubic feet, a 14 foot for 700, and 24 foot for 1400. How many of each type of truck should the company purchase? All right. Well, we have to have some variables. We have usually the way to do it is we say the first one is X1, second one is X2, third one is X3. You could do XYZ or X1, X2, X3, however you want to do it, just as long as you label what your variables are and then say, okay, the X1 is that 10 foot, the X2 is the 14 foot, and the X3 is the 24-foot trucks. Okay, so that's your first part. Now, what we have to do is we have to make a model. Well, we know if we take the number of these plus the number of these plus the number of those, that has to be the total number we want. And instead, we want 25 trucks, so we have to have 25. Then we have to multiply the poundage by each truck. So 350, or cubic feet rather, 350 cubic feet times x1 plus the 700 cubic feet times x2 plus 1400 cubic feet times x3 equals a total cubic feet of 28,000. Okay, so that's going to be your total capacity. All right, so now we can form an augmented matrix with this. And guess what? We have two equations, three unknowns, so we're going to be having a variable we have to pull into effect here. And so that's going to be our augmented matrix. We'll multiply the first one times the negative 350, add it to the second one. They're taking a they're just making it easier that way. But either way, if you multiply it by 350, it's going to be the same as dividing the other one by 350. So you get the same answer. And then after this, we're going to have to take this row times negative 1 plus that row. And then when we do that, we get this. And so now our matrix is in reduced form. We have 1, 0, and then 1, 0, and it's as far as we can go. So now we're going to say that was x1, x2, x3. So we're going to say x3 is equal to t. Okay. And here we go. X3 is t. And so if that's the t, x2 is equal to, it's going to be a minus 3t plus 55. And x1 is going to be, now this is going to be a minus, or a positive 2t minus 30. So you're going to take it over to the other side. And so that's going to be our solution to this real world problem. So let's state it into the terms of the original question. So those are representing the numbers of the trucks. They might be non-negative whole numbers. I mean, they have to be rather. You can't have a negative truck. And so T basically is some kind of a non-negative whole number, but it has to be less than 25 because remember, 25 is the total. And so the first and second equations also place restrictions on t. So that kind of gives us a restriction. It says 2t minus 30 has to be greater than or equal to 0. And so if we solve that for t, take 30 over, divide by 2, t has to be greater than or equal to 15. This one, if we take 55 over, divide by negative 3. Now remember, when you divide by negative, switch the inequality sign. And so t has to be less than 18 and a third. Well, we can't really have 18 and a third trucks. So basically, it has to be between 15 and 18 is going to be the number of trucks we're going to do. So only possible values are 15, 16, 17, or 18. So those are the four possible solutions for t. And so then you could get four possible solutions for your x2, x1. Okay. So if we make that into a table, that's the only ways we can do it. We have 15 as t, so x1 ends up being 0. 16 for t, x1 is 2, and then 4, then 6. And then when we have that, that's 10, 7, 4, 1, and that's 15, 16, 17, 18. So that's our t's, and so that's your x's as well. And then it makes your other variables that way. Okay, so hopefully that will help you get at least a start, and I'll come back with exercises.